Hi students, I am Manish Gupta. I teach physics, AP Physics 1, 2, mechanics and electromagnetism. Also I teach maths, AP Calculus, AB, BC and algebra coordinates. Now here we are going to learn AP Physics 1. We will start Unit 1 with kinematics. So students, first our focus question will be, what's the difference between vector and scalar quantity? Students, now think about, your friend is saying that he is applying a 10 Newton of force. You are going to ask him in what direction you are applying. Another friend is saying that box is of 100 kg. You are not going to ask in what direction is that of box is of 100 kg. So some quantities involve both magnitude and direction. Those quantities are known as vector quantities, and the quantities which are good with only magnitude or with some proper units are called as scalar quantities. First we are going to discuss motion with constant velocity. So students, kinematics is the study of motion without regards to the forces causing the motion. Forces we will learn in dynamics. Study of forces is called dynamics. So students, our first term is vectors. Vectors are the quantities that have direction and magnitude. For example, velocity, displacement and force. If I am going to say I am applying a force of 100 Newton, so you are going to ask in what direction you are applying the force. And if some car is moving with some speed 10 meter per second, and let's assume in its direction, then this is the velocity. You see, magnitude and direction. Next term we have scalars. So the students, quantities that only have magnitude, for example, mass, temperature, speed, time. If I am going to say temperature of this room is of 17 degrees Celsius, you are not going to ask in what direction is of 17 degrees Celsius, right? So the quantities which are good with only magnitude and proper unit, that those quantities are scalars. Our next term is, students, position, where an object is compared to some reference point. That reference point is known as origin. Now, if we are talking about one-dimensional motion, what we do, we can take one-dimensional motion, that is motion along a straight line. We can take that path or a straight line as a x-axis, and on x-axis, we can take some origin position, right? This can be 1, 2 marking of this, right? This is -1, -2. This direction will be as positive and other direction will be of negative. So some particle is moving, so let's assume it's moving from here to some here, right? Then you will see, now we'll be able to compare, yeah, it is starting moving from -1, and here will be some position, it's moving to this position, right? So see, it's easy to compare here one-dimensional movement, right? Now students, let's go for the two-dimensional motion. Two-dimensional motion is like motion in a plane, right? So students, if you have to compare or think about 2D motion, then what you have to do, you have to take two perpendicular axes, x and y. Now, if I have to say this is some position and a particle is moving to here to somewhere here, now we will be able to compare these positions, right? This position have some x coordinate, right, and some y coordinate. So we can write this position as x1, y1, right? And if you'll see this position, it has also some x position, we can say x2, and some y position, right? We can say that y2, right? So here you will see we can now compare think about the, now we are able to discuss about this movement. It's moving from this position A to this position B. Okay, so now let's come to the another term which we encounter, displacement. In kinematics we encounter another term, displacement. So students, displacement is change in an object's position. So students, displacement is change in an object's position. Like if we are talking about one dimensional motion, 1D motion, what we will do? We will take that path as x-axis, and if a particle is starting from this xi, this initial position somewhere here, and going to some position here, right? So this here displacement will be change in object's position, that is final position minus initial position. So delta x will be x final minus x initial. Students, we encounter also a term distance. What is distance? So distance is length of path an object travels as it moves from its initial position to final position. Like let's take two cases. We are taking 1D. In 1D we are going to take two cases. See, if a particle is moving, this A started moving from A and moving to somewhere B, right? It's not changing the direction, right? Now take the second situation. Here again we are taking 1D motion, right? So particle is moving A to some point B, then turning back and moving back to some point C. Now if I will ask, in the first case, what is the distance or displacement? If I say this is initial position xi and this is in final position xf, so you are going to say your displacement and distance both have the equal magnitude, right? Distance will have xf minus xi here, right? And also displacement we have here x final minus x initial. Here plus and minus for displacement matters, but for distance it doesn't matter. Distance is either positive or 0, right? Now students, because distance is the path length, right? Now go for the second situation. If we say this is the position x1, this is the position x2, and this is the position x3, then if we will ask displacement, then displacement will be final position. Final position is the x3. So x3 minus x1. But if we have asked about distance, then if we have asked about the distance, then what we will do? Distance will be, see, it's moving x1 to x2, right? So first we need to take x2 minus x1 magnitude of this, plus we also need to add this path length. This path length will be x3 minus x2. x3 minus x2, right students? We have to add up this. Now if you'll see, displacement tells you how far you are from you are started, right? But distance tells you how far you have traveled. Displacement tells you how far you are from you are started. But distance tells you how far you have traveled, right? Students, see, take a 2D motion in the plane. If we have asked about the displacement for A to B, then what we will do? We will take this as the displacement. This will be the displacement, right? If a particle is starting from A and moving on this path and reaching to point B, then displacement will be this straight path having direction A to B. But if you have asked about distance, then what you have to do? You have to take this measure of this path length, right? So I hope you understand difference between distance and displacement.